the video and work on these questions for me and then come back. Okay, now I will go over them. So for number 1, 0, 5, and 5, 0, our slope is 0 minus 5, which is negative 5, over 5 minus 0, which is 5, so negative 1. And slope-intercept form is y equals mx plus b. So actually our y-intercept we already have, 5. So we have y equals negative x plus 5. You could say negative 1x if you wanted to, but you don't need the negative 1. For number 2, our slope is negative 1 minus 3, which is negative 4, over 2 minus negative 1, which is 3. And here we have to find our y-intercept. So y equals mx plus b. So choose whichever points you want. Let's do this first point. So then 3 for our y, negative 4/3 for our m, negative 1 for our x, plus b. 3 equals thirds plus b. So b is 3 minus 4/3. If you think of this as 9/3, it's 4/3 plus b. Oops, sorry about that. So 9/3 equals 4/3 plus b. If you subtract 4/3 from 9/3, you get 5/3. So then our slope is negative 4/3. Our y-intercept is 5/3. So our answer is y equals negative 4/3 x plus 5/3. You could also have solved this with point slope form if you wanted to, and done y minus either one of the y values, let's say 3, equals slope times x minus the x value, which is a negative 1. X minus a negative 1 is plus 1. And if you go through and solve and simplify, you'll get the same answer. Let's talk a little bit about linear relationships. So that's the slope-intercept form that we just did in the warm-up. Y equals mx plus b. Slope-intercept form, where m is our slope and b is our y-intercept. But here, what is slope? I mean, it's m, but what does it mean? Well, first we have just the equation piece of it, change in y over change in x, which is y2 minus y1 over x2 minus x1. That's really the average rate of change. That's what a slope is. It's how much y is changing with respect to x, average rate of change between 2 points. It measures steepness, which is not really a mathy term. But in terms of steepness, so I'll make it more steep. So there's a pretty steep slope, and it's positive. And there's a pretty steep slope that's negative. But essentially steeper means you have a greater y value. So when you do change in y over change in x, you end up with a higher value, either a higher positive value or a higher negative value. And by higher, I mean basically the magnitude, like the absolute value is larger. Then we have y-intercept. What is a y-intercept? Well, it's the y value when x equals 0. Sometimes it's called the initial value, which is really the same thing. At 0, what's our y value? And it's also the point where the graph intersects the y-axis. So y-intercept, let's say here's our function. It's right there because it's right where it crosses over the y-axis. So there's two practice worksheets, rate practice and interpreting slope practice. I'm going to show you a couple problems from each. So first for our rate practice. So we have a graph, a bunch of graphs. This one in particular, number 19, shows the relationship between the distance traveled by a motorist and the time of travel. And we're going to find the slope of the line between the 2 points we're given, and we're going to write a sentence that states the meaning of the slope. So first we'll just calculate the slope. So our change in y, we have 240 minus 80 over 6 minus 2. 240 minus 80 is 160. 6 minus 2 is 4. So this simplifies to 40. I'm going to leave it as 40 over 1 because technically when you do rise over run and you were to graph it, you'd go up 40 over 1, up 40 over 1. And now we look at our units. The top was the change in y, so that's the distance in miles. The x's was time in hours. So what this means is that the motorist traveled 40 miles per hour. Or it could have been per 1 hour or in 1 hour. Okay? So that's what that means, is our speed in miles per hour, because it's change in y over change in x, miles over hours. Let's look at number 20. This is the relationship between the cost of the building and the depreciation allowed for income tax purposes. So I know more about depreciation than your average person since I was an accountant. I don't remember them all, but there's like, I don't know, 5 or 6 or 7 different depreciation methods to depreciate inventory and things like that. Not that you care, I don't really care either. But basically depreciation is when you put the value on your books, you start with the cost, then over time the value goes down. So when you count it on like your on your balance sheet as far as your assets, what you own, the value decreases. Same with cars. As soon as you drive a car off the lot, I don't know if you've heard this, it depreciates by a certain amount. So anyway, that's depreciation. Basically, it's a decrease in value over time. So first we find the slope. So y's are 150 minus 0 over 0 minus 30, which is 150 over negative 30, which is negative 5 over 1. And so now our y's were thousands of dollars. And our x was years. And so what this tells us, negative 5, that's really negative $5,000. And what it means is that the value of the building depreciates, which is really just fancy word for decreases, by $5,000 every year. Okay, so on your own, go through and do the rest of these and check your work. And we have interpreting slope, or as I wrote it, interpreting slop, but we'll just ignore that. So these are kind of cool. I don't know why I'm telling you that I think they're cool, but I think they are. So this first one, we have a water tank. It has an inlet pipe, so the water's going into the tank with a flow rate of 5 gallons per minute. And then there's an outlet pipe, which is the water's flowing out by 3 gallons per minute. So the inlet is going to be a positive 5, and the outlet pipe is going to be thought of as like a negative 3 because it's decreasing. We have a graph that shows the number of gallons in the tank after a certain amount of minutes called x. And we're going to give the slope of each part of this. So 0 to this point, we're going to call that just part 1, 2, 3, 4. So whenever it kind of switches definition or kind of has a sharp corner, that's a new spot. So the first section, our slope, our first section is really just here. It's between 0 and 3. So our change in y, 15 minus 0, because this is x, this is y, over 3 minus 0 equals 5. And then in terms of our units, and this is really just a slope, so 5 over 1. So our y's were gallons, our 1 was minutes. So this is 5 gallons per minute. And so what that means, and we're not actually going to write a complete sentence because I don't feel like it, but we're looking at, as far as our pipes go, 5 was our inlet flow rate, and -3 was our outward flow rate. So this means as far as like which pipes are open, since it equals 5, since the rate is 5, the inlet is open and the outlet is closed. If this doesn't make sense yet, hopefully it will as we go. The second part, so right here, is going to be from 3 to 5. So our slope is 19 minus 15 over 5 minus 3, which is 4 over 2, which is 2 gallons per minute. And so if it's 2, basically it's how do you make 2 with 5 and -3? Well, you add them together. So this means that the inlet and outlet pipes are both open. I'm going to switch colors just so we don't get confused, or you don't get confused rather when you look at this. So the third section is right here, and so that's from 5 to 8 minutes. So then our slope, our change in y, it's really just 19 minus 19. Y doesn't change, over 8 minus 5, which is 0 over 3, which is 0 gallons per minute. And it should make sense that the slope is 0. If you look here, this is a horizontal line, right? So if it's 0 gallons per minute and nothing is happening, that means both the pipes are closed. For the fourth one, which is right here, 8 to 10 minutes. So our slope is 13 minus 19 over 10 minus 8, which is -6 over 2, which is -3 gallons per minute. And -3, again, our values were -3 and 5 for our rates. So if -3 is our overall rate, then the outlet must be open. So outlet open, and the inlet is closed. So do the rest of this, the second example on this page and a couple more on the next page, and check your work.